path we tread, breaking through.
Welcome back to the My Next Startup Edge podcast, the podcast that gives your startup the edge. I'm Dirk Lammertz, your host. If you're an entrepreneur, innovator, or startup founder looking to disrupt industries, you are in the right place. Today, we are diving into one of the most powerful mindsets in business, first principles thinking. This approach is what separates the companies that lead markets from those that constantly play catch up. So you are in for a special episode today. We'll start by exploring what first principles thinking is and why it is the best, if not the only way of coming up with truly innovative solutions for big problems. We'll then look at case studies of companies that transformed their industries through first principles thinking. And finally, and most important for this audience, we'll discuss how you can apply first principles thinking to your startup, to overhaul your design philosophy, to break away from conventional constraints in your product development, and to delight your customers with products and services the world did not think were possible. Ready? Let's get started. Segment 1. What is first principles thinking? Most people think in terms of analogy-based reasoning, meaning they rely on what has been done before and tweak it slightly. This is why industries tend to evolve incrementally rather than experience exponential breakthroughs. However, first principle thinking allows for radical innovation because it forces you to start from scratch, removing bias and limitations imposed by conventional wisdom. First principle thinking is a problem-solving approach where you break a complex issue down into its most fundamental truth and then reason up from there. Instead of relying on conventional wisdom and analogies, essentially doing things the way they've always been done, you question long-held assumptions and construct solutions from the ground up. Think of first principles as the atoms of knowledge. First principle thinking reveals the fundamental truths of a problem while eliminating imaginary constraints rooted in tradition or beliefs. Using first principles thinking enables you to come up with breakthrough solutions that competitors using traditional analogy-based thinking will never envision or even deem possible. Let's take an example outside of business. Cooking a meal. A great way to understand first principle thinking is by contrasting a cook who follows recipes with a chef who creates new dishes from fundamental principles. A cook thinks by analogy, following established recipes, relying on precedent rather than a deep understanding. They assume the steps in a recipe are fixed and that deviating from them could lead to failure. Their success depends on replicating what had already been done rather than questioning whether the process can be improved. They focus on execution, not innovation. They are bound by convention and don't think critically about whether a better way exists. By contrast, a chef doesn't just follow recipes. They think in terms of first principles, which allows them to understand the science behind cooking and create new dishes from scratch. They break down cooking into its fundamental principles, such as heat transfer, emulsification, and flavor balance. Instead of copying past successes, they rebuild recipes from the ground up using food science principles. They ask, what makes a cake rise? Instead of just using baking powder. If they don't have an ingredient, they identify its role and replace it with something that achieves the same function. They can innovate, creating new recipes, experimenting with textures and flavors, and discovering better methods. Most companies think like cooks. They copy existing business models, incrementally improving rather than questioning assumptions. They look at competitors and try to tweak features rather than rethink the problem. They rarely disrupt markets and instead just iterate on what exists. Disruptive startups think like chefs. They challenge assumptions, often in industries outside of their own one, deconstruct problems to fundamental truths, and build innovative solutions or new business models from scratch. They ask, what problem are we actually solving and how can we achieve this in a fundamentally different and better way? In doing so, they sometimes even create or redefine entire industries. Segment 2. Case studies of great companies redefining their industries through first principle thinking. First principle thinking is the foundation behind some of the biggest success stories in business and technology. But at first principle thinking seems to be an abstract construct, a theoretical or academic topic. I myself initially struggled to see how I can apply it to actual real-world situations. I found that the best way of understanding how first principle thinking works is by studying how some of the best visionaries in companies used it. Used it not just to optimize an existing product, service, or business model, but to reinvent their industries from the ground up. The companies we'll be looking at together in quite some detail in this podcast are Apple, Spotify, Tesla, and SpaceX. Let's dive into how these companies so successfully applied first principles thinking and what lessons we all can learn from them. Our first example, the iPhone. Do you remember the cute blue Nokia phone? Or the Motorola Razr flip phone? The first cell phone that could be used as a decent speakerphone. Both of these phones were innovative, but neither one disrupted the cell phone industry. Neither one redefined the cell phone industry. Because at the end of the day, these were just phones. Before the iPhone, phones were devices for calling and texting, with small keyboards and limited functionality. Apple ignored all existing assumptions about what a phone should be and designed the iPhone using first principles thinking, which meant breaking down what a mobile phone was at the time and reconstructing it based on fundamental truths. The result? Steve Jobs introduced the iPhone, a widescreen iPod with touch controls, a revolutionary mobile phone, and a breakthrough internet communicator, all in one device during his keynote at Macworld 2007. The iPhone disrupted not just mobile phones, but music, photography, and the way we interact with the internet. Here are the first principles that led to its revolutionary design. Principle number 1. A phone does not need a physical keypad. The pre-iPhone industry assumption was that phones must have physical keyboards because people need tactile feedback to type. First principle thinking led to the realization that if typing is needed, it does not have to be physical. A digital on-screen keyboard could be more flexible and adaptive. The iPhone innovation was to remove the physical keyboard, making way for a full touchscreen interface. Principle number 2. Build a pocket computer, not just a phone. The pre-phone industry assumption was that a phone is primarily a calling and texting device and that internet browsing on a phone is secondary and limited. First principle thinking led to the realization that a phone is essentially a pocket-sized computer that should be able to handle multiple tasks beyond making phone calls and texting, including web browsing, music, and apps, and that the computing experience should be seamless, just like on a desktop. The iPhone innovation was to design the iPhone as a multi-purpose mobile computer rather than a device for just calls and text. This led to mobile-first software, intuitive touch gestures, and the App Store. Principle number 3. The best input device is the one that adapts. The pre-iPhone industry assumptions were that phones needed buttons for input, with screens only used as displays, or that people need styluses to interact with touchscreens. First principle thinking led to the realization that a finger is the best stylus. It's natural, intuitive, and always available, and that the interface should adapt dynamically depending on the user's needs. The iPhone innovation was the introduction of multi-touch technology, allowing users to navigate with pinch to zoom, swipe, and tap without needing a stylus. This was the birth of gesture-based interfaces. Principle number 4. The internet should be fully usable on mobile. The pre-iPhone industry assumption was that mobile web browsing should be a scaled-down version of a desktop experience, and traditional phones use web or wireless application protocol browsers, which were limited and clunky. First principle thinking led to the realization that the internet experience should be the same on a phone as on a computer, and the mobile browser should be redesigned for a touchscreen. The iPhone innovation was to create Mobile Safari, the first full desktop-class browser on a phone, so that websites could be viewed as they were meant to be seen, revolutionizing mobile browsing. And principle number 5, software not hardware defines the experience. The pre-iPhone industry assumptions were that mobile hardware, keypads, small screens, define a phone, and that software is secondary and mostly for system-level functions. First principle thinking led to the realization that software, not just hardware, should define the phone's capabilities, and that a flexible operating system should allow the phone to evolve over time with updates. The iPhone innovation was that Apple built iOS, a full-fledged touch-based operating system that could be updated with new features. This allowed for app development, leading to the creation of the App Store, which completely reshaped the mobile industry. Apple's first principles approach didn't just improve mobile phones, but created an entirely new category of smart mobile devices. It established new form factors like tablets, the iPad, and wearables, the Apple Watch, where software and seamless integration became key. And it created the app economy, allowing independent developers to create a multi-billion-dollar industry. Apple's first principle thinking with the iPhone teaches us in startups a crucial lesson. Don't just improve existing products. Fundamentally rethink what they should be. Instead of asking, how can I make this better? Ask, what are the fundamental truths about this problem? And if I started from scratch, what would I create? Our next example, Spotify. Spotify's approach to music streaming is a textbook example of first principles thinking. Instead of iterating on traditional music distribution models, Spotify deconstructed the core problem of music access and rebuilt the solution from fundamental truths. Here are the key first principles that shaped Spotify's streaming service. Principle number 1, music is about access, not ownership. The pre-Spotify industry assumptions were that people want to own music, buying physical CDs, digital downloads, or MP3s, and that the best way to distribute music is through album sales or paid downloads. Even Steve Jobs believed in this assumption in the early days of the iTunes Music Store, which made Apple reject the idea of a music subscription service. First principle thinking led to the realization that the core value of music is listening, not ownership. If people don't need to own a song to enjoy it, then a subscription-based model could be viable, and the internet allows for instant access to any song, without storage limitations. The Spotify innovation was to introduce music streaming, allowing users to play any song instantly instead of purchasing individual tracks, and shifted the music business from ownership, buying albums, to access, monthly streaming subscriptions. Principle number 2. Piracy is a distribution problem, not just a legal issue. The pre-Spotify industry assumptions were that music piracy is illegal but unavoidable, since people pirate music because they don't want to pay, and the best way to stop it is through legal enforcement. First principle thinking led to the realization that people pirate music because it's more convenient than legal alternatives. The problem isn't that people won't pay, it's that there wasn't a better legal option. If a legal service was as fast and convenient as piracy, people would choose it. The Spotify innovation was to create a legal, ad-supported, free tier, allowing users to stream music without paying upfront, while making the paid experience, Spotify Premium, better than piracy, with high-quality audio, no ads, and offline listening. Principle number 3. Music should be personalized and not just categorized. The pre-Spotify industry assumptions were that people browse genres and charts to find new music, and that radio stations and music critics determine what's popular. First principle thinking led to the realization that every listener has unique music taste that can't be grouped into broad categories, that instead of relying on manual curation, AI and data can create highly personalized recommendations, and that music discovery should be automatic and frictionless. The Spotify innovation was to build a data-driven recommendation system using AI and user listening habits to launch Discover Weekly and Daily Mix, creating automated, personalized playlists, and to use machine learning to predict which songs users would like before they even searched for them. Principle number 4. The best experience requires seamless streaming, not downloads. The pre-Spotify industry assumption was that music should be downloaded and stored locally on CDs, MP3 players, or hard drives, because streaming music over the internet is too slow and unreliable. first principle thinking led to the realization that the internet does allow instant access to content, eliminating the need for storage. Instead of waiting for downloads, buffering and caching can create a seamless streaming experience. If streaming is fast enough, users won't care about owning music files. The Spotify innovation was to use adaptive streaming technology to minimize buffering and provide instant playback, develop music caching so frequently played songs don't need to be reloaded, and allow users to create offline playlists, blending streaming with temporary local storage. And principle number 5, the music business should be subscription-based, not one-time purchases. The pre-Spotify industry assumptions were that artists and labels make money through album sales and single downloads, and that music pricing is fixed. You pay per song or album. First principles thinking led to the realization that a subscription model ensures consistent revenue for artists and labels. Instead of selling songs individually, platforms should charge users a flat monthly fee for unlimited access, and the music industry should be aligned with how people actually consume music, continuously and not one-time purchases. The Spotify innovation was to launch Spotify Premium, allowing users to pay a fixed monthly fee for unlimited ad-free music. Spotify built a royalty-sharing model where artists are paid based on actual streams instead of fixed purchases, and Spotify created a freemium to premium conversion using ads to support free users while incentivizing them to upgrade. Spotify's first principles approach transformed music from an ownership model to a subscription-based service. It reduced piracy by making legal streaming more convenient than illegal downloads. It revolutionized music discovery with AI-driven recommendations and curated playlists. And it forced competitors, Apple Music, Amazon Music, YouTube Music, to adopt streaming-based models. It also created a data-driven music economy where artists can track streams and audience engagement in real time. Spotify's first principle thinking with its music streaming strategy teaches us in startups a crucial lesson. Don't just iterate on existing business models. Redefine how value is delivered using first principles thinking. Instead of improving on legacy models, break down the core problem and reimagine the best possible solution. From smartphones and music streaming services to self-driving cars. Our next example, Tesla. Tesla's approach to self-driving electric vehicles, or EVs, is a prime example of first principles thinking. Instead of iterating on traditional automotive industry assumptions, Tesla deconstructed the problem of transportation and vehicle autonomy and rebuilt the solution based on fundamental truths. Here are the core first principles that shaped their revolutionary approach. Principle number 1, cars are computers on wheels, not just mechanical machines. The pre-Tesla industry assumptions were that cars are primarily mechanical with some electronic components for entertainment and navigation, and that the driving experience is defined by the physical design and engine performance, rather than software. First principle thinking led to the realization that a car is fundamentally a transportation device that moves people efficiently and safely, but that the brain of the car does not have to be a human. It can be a software-driven AI system. If computers can make real-time decisions in financial markets, why can't they drive cars? The Tesla innovation was to reimagine the car as a software-defined machine, treating it more like a computer on wheels than a traditional vehicle. This allowed Tesla to develop over-the-air software updates to continuously improve vehicle performance and self-driving capabilities. Principle number 2. Full self-driving can be solved with vision and does not require LiDAR. The pre-Tesla industry assumptions were that self-driving cars must rely on LiDAR sensors, which provide light detection and ranging to map the environment in 3D, and that autonomous driving requires high-definition pre-mapped roads instead of real-time adaptation. First principle thinking led to the realization that humans drive using only vision. Our eyes and brain process visual inputs to navigate roads, and that cameras can be designed to exceed human vision with 360-degree coverage, night vision, and object recognition. Neural networks trained on billions of real-world driving scenarios can replicate human decision-making without requiring expensive LiDAR. The Tesla innovation was to eliminate LiDAR from its self-driving systems, using cameras and an eye-based vision processing to navigate roads like a human. This approach allows Tesla's AI to adapt to any road in real time, rather than relying on expensive pre-mapped environments. Principle number 3. The key to full autonomy is fleet learning and real-world data. The pre-Tesla industry assumptions were that autonomous driving technology must be developed in a controlled lab or testing environment, and that AI models should be trained in simulations than relying on real-world data. First principle thinking led to the realization that no simulation can match the complexity and unpredictability of real-world driving. If millions of Tesla cars are already driving billions of miles, they can be used as real-world data collection agents. The more data Tesla collects, the smarter its AI becomes, making self-driving incrementally safer and more reliable. The Tesla innovation was to equip its cars with autopilot hardware, passively collecting real-world driving data from millions of miles driven. The Tesla neural network continuously learns and updates its self-driving AI based on real driver behavior and edge cases. This massive data set allows Tesla's AI to train on real traffic conditions, accidents, and unexpected obstacles, making it more adaptable. Principle number 4. EVs should be designed for maximum efficiency and simplicity. The pre-Tesla industry assumptions were that electric vehicles should resemble gasoline cars with minor modifications, and that EV performance in terms of size, speed, and range were severely limited by battery size and technology. First principles thinking led to the realization that a car is just a battery-powered electric motor and a software-driven control system, and that maximizing efficiency and performance requires rethinking aerodynamics, battery management, and energy recovery. Traditional gas-powered designs aren't optimized for EV performance. The entire structure had to be rethought. The Tesla innovations were to design ultra-efficient EV motors, improving range without increasing battery size. Use gigacast manufacturing to simplify vehicle structure, reducing weight and improving efficiency, and implement software-optimized energy management like regenerative braking to enhance driving range. And principle number 5, charging should be as convenient as gas refueling. The pre-Tesla industry assumption was that charging infrastructure for EVs is secondary to vehicle sales, and long charge times make EVs impractical for long-distance travel. First principle thinking led to the realization that EVs will only replace gas-powered cars if charging is as fast and convenient as refueling. That fast charging networks must be built alongside vehicle production, not as an afterthought, and that battery chemistry can be optimized to increase charge speed without degrading lifespan. The Tesla innovations were to build the supercharger network, ensuring widespread fast charging stations to reduce range anxiety. Develop battery thermal management systems to support faster charging without excessive heat degradation. And introduce long-range batteries, allowing Tesla EVs to drive over 400 miles on a single charge. Tesla's first principles approach revolutionized the design thinking approach, defining EVs as software-defined vehicles rather than just electric versions of gas-powered cars. It created a self-improving AI-driven fleet. Each Tesla vehicle contributes to a real-world machine learning system, making the AI smarter with every mile driven. Made over-the-air software updates a norm, Tesla redefined what it means to own a car by enabling continuous feature upgrades via software. It lowered costs by eliminating expensive components. Tesla's rejection of LiDAR and legacy automotive suppliers reduced manufacturing costs. Tesla's self-driving EV strategy teaches us in startups a critical lesson. Instead of making small improvements, rethink the entire system from the ground up. And finally, our last example. In the words of Buzz Lightyear, to infinity and beyond, SpaceX. SpaceX's reusable rocket design was built using first principle thinking, which meant breaking down the cost structure and re-engineering constraints of traditional rockets and rebuilding them from the ground up based on fundamental truths. Here are the core first principles that led to this breakthrough. Principle number 1. Rockets are expensive because they are discarded after one use. The pre-SpaceX industry assumption was that rockets, except for the space shuttle, must be disposable, meaning each mission requires an entirely new rocket. That the cost of spaceflight is high because building rockets is inherently expensive. First principle thinking led to the realization that the materials that make up a rocket, aluminum, carbon fiber, fuel, are only a small fraction of the total cost, and the real cost comes from complex manufacturing, testing, and single-use components. The SpaceX innovation was to design rockets that could return, land, and be reused multiple times instead of being discarded. The Falcon 9 became the first orbital class rocket capable of reusability, drastically reducing cost. Principle number 2. The high cost of space launches comes from complex manufacturing and custom parts. The pre-SpaceX industry assumptions were that aerospace parts are highly specialized and custom built, making them expensive, and that manufacturing rockets is an artisanal, slow process with limited production runs. First principle thinking led to the realization that a significant portion of aerospace cost comes from low production volumes and reliance on expensive suppliers. Manufacturing efficiency could be increased by vertically integrating production and using mass production techniques. The SpaceX innovation was to vertically integrate its supply chain, manufacturing 80 to 90% of its rocket parts in-house instead of relying on legacy aerospace contractors. Use automated assembly lines and rapid iteration to lower cost and speed up production, and standardize components across different rocket models, increasing scalability. Principle number 3. Fuel costs are minimal compared to the cost of rocket structure. The pre-SpaceX industry assumption was that rocket fuel is one of the biggest costs of a space mission, meaning that there is little financial incentive to make rockets reusable because the fuel savings wouldn't justify the redesign. First principle thinking led to the realization that the cost of rocket-grade kerosene and liquid oxygen is less than 1% of the total cost of a launch. As a result, the real savings would come from reusing the entire rocket hardware, not from reducing fuel cost. The SpaceX innovation was to design Falcon 9 with reusability in mind, allowing the first stage to return and land vertically after launch. Instead of focusing on minor fuel saving, SpaceX invested in landing and refurbishment technologies to lower overall mission cost. Principle number 4. Rockets do not need to be disposed after one flight. This pre-SpaceX industry assumptions were that rockets experience extreme stress and cannot survive re-entry, and that the best way to make spaceflight affordable is to make rocket components cheaper, not necessarily reusable. First principle thinking led to the realization that airplanes withstand multiple flights through turbulence and mechanical stress, so why can't rockets do the same? Instead of designing rockets for disposable, build them with durable materials and robust thermal protection for multiple flights. The SpaceX innovations were to develop grid fins and cold gas thrusters to guide the rockets back through the atmosphere, engineer landing legs and automated descent systems to enable safe, controlled landings, and develop heat shielding and rapid refurbishment techniques to prepare rockets for multiple launches. And principle number 5. The aerospace industry over-engineered components for extreme margins of safety. The pre-SpaceX industry assumptions were that every space mission is unique and requires custom-designed parts, and that redundancy should be maximized even if it increases cost exponentially. First principle thinking led to the realization that many aerospace components were over-designed for one-time use, increasing weight and cost, and that rockets should be modular and standardized to maximize efficiency. The SpaceX innovations were to introduce common engine designs, for example, Merlin engines for Falcon 9 and Raptor engines for Starship. To streamline production, develop Falcon Heavy by strapping together 3 Falcon 9 boosters, reducing the need for an entirely new rocket design, and use software-driven avionics to reduce hardware complexity and increase flexibility. SpaceX's first principles approach reduced launch cost by 90%. Traditional launches cost more than $200 million, while a Falcon 9 launch cost approximately $50 million. Accelerated launch cadence as reusable rockets allow for faster, more frequent launches, opening up new opportunities for commercial space missions. Enabled the space economy as lower cost led to the rise of satellite mega constellations like Starlink, asteroid mining startups, and a realistic path towards Mars colonization. And it forced an industry shift with NASA, Blue Origin, and others now prioritizing reusable rocket designs, following SpaceX's lead. SpaceX's design of reusable rockets teaches us and startups a critical lesson. Don't accept industry norms. By questioning every assumption, startups can find cost efficiencies, challenge outdated processes, and in the process build entirely new markets. Segment 3. How can you, as a startup, apply first principle thinking? Startups operate in a fast-changing environment where conventional wisdom can be a major roadblock. If you only iterate on what already exists, you won't differentiate yourself and you won't disrupt the market. First principle thinking allows startups to identify hidden constraints, find inefficiencies that competitors ignore or don't dare to tackle, create unique value propositions, develop products or services that aren't just slightly better, but fundamentally different. Make big leaps instead of small tweaks. Challenge outdated product or service solutions and business models, and reinvent entire industries. So, how can you apply first principle thinking to your startup? Here's the playbook for applying first principle thinking. It consists of these 5 steps. Step number 1, identify and challenge assumptions. Every industry operates with default assumptions, beliefs that are taken for granted. Identify these assumptions. Ask, what do we assume to be true about this problem? Then challenge industry norms and break down sacred cows. Ask, why are things done that way? Is it for a truly fundamental reason, or is it because that's how we've always done it? Step number 2, break the problem down into fundamental truths. Strip the problem down to its fundamental building blocks, the fundamental truths. Ask, what do we absolutely know to be true about this problem? Identify the most basic facts about the problem that cannot be broken down further. Focus on physics, economics, and core constraints, not opinion or best practices. As a result, you're left with undeniable facts about the problem. Step number 3, reconstruct the solution from the ground up. Once you strip a problem down to its core, build a new solution based on first principles, not on existing industry standards or tradition. Ask, if we had to solve this from scratch today, without baggage, in a better way, what would it look like? If done right, you will have discovered and designed a truly innovative solution, not constrained by old ways of thinking. Step number 4, prototype and experiment quickly. Once you create a first principle-based solution, put it to the test. Visionaries often get stuck in big ideas, but fail to execute. The fastest way to test first principle thinking is real-world experimentation. Create prototypes or minimum viable products to validate your key assumptions about your new way of developing a solution or deploying a business model. Rapidly iterate based on feedback, data, and learnings. Focus on speed and execution, not perfection. Adapt based on facts and findings, not based on conventional wisdom or long-held beliefs. And step number 5, scale the disruptive innovation. Once the new model is proven, you must scale it aggressively to redefine the industry. Move from early adopters to mainstream users. Build an ecosystem around the disruption. For example, Apple's App Store or Tesla's EV charging network. This does not only add value for your customers and improve the customer experience, but it also increases switching cost and helps with customer lock-in. Force the industry to adapt your model instead of operating by their terms. Think of how you can make this work for your startup. After all, you don't really want to just make an existing product slightly better when you have the option to fundamentally rethink the problem and redefine your industry. Right? Let me finish with some closing thoughts. This was an intense episode. Respect and congratulations to you if you made it all the way to the end. I think the time and attention you devoted to this episode will pay off big time. First principle thinking is a superpower for startups. It's the mindset that turns ordinary into extraordinary, and the reason why the companies we looked at have redefined their industries. Don't just accept how things are done. Question everything. Challenge assumptions. Rebuild from the ground up. That's how you create something truly revolutionary. Thanks for tuning into this episode of the My Next Startup Edge podcast. If you found this valuable, please subscribe, share it with your network, and let me know what other topics you'd love to hear about. Until next time, keep building, keep pushing boundaries, and keep turning innovation into impact. And remember, never accept conventional wisdom if you want to change the world.
In the shadows, ideas ignite. A spark of brilliance cuts through the night. Chasing dreams, the edge of the unknown. Building futures, foundations of stone. Start a pledge, the power